recording. All right, letter C was 8x squared plus 4x plus 2. It's easy to look at your smallest number. Here, our smallest number was 2. We were able to divide them both by 2. Here, our smallest number was 5. We were able to divide both by 5. So this is 2 without any x's. So the biggest term we could possibly divide everything by is 2. Because if I have an x, I won't be able to divide 2 by an x. So that becomes 2 on the outside. 8x squared divided by 2 is just 4x squared. 4x divided by 2 is a positive 2x. And then 2 divided by 2 becomes 1, right? Remember, letter D is 12x minus 20. I can divide 12x by 12, but I can't divide 20 by 12. I can divide 12 and 20 by 2. I can divide 12 and 20 by something even bigger than 2. 4. So if you want to list your factors of 12, the factors of 12 are, you can ignore 1 and 12, right? But we can divide 12 by 2. We can divide 12 by 3. We can divide 12 by 4. And we can divide 12 by 6, right? And then our factors of 20 are 2, 4, 5, and 10. So we have common factors, they're called. 2 and 4 are both common factors, and then 4 is the greatest common factor, the biggest number I can divide them both by. Good. So 12x divided by 4, see if I can fit it. It's going to be 3x. Negative 20 divided by 4 is a negative 5. So if you're not sure what term to use to pull it out, you can make a list of every number I can divide 12 by and every number I can divide 20 by. Sorry, that's this one. E is interesting. E has no numbers. It just has x's. So we have x to the third plus x. If I think about that, these are 3 x's multiplied together, and this is just 1x, right? So I can also write it as x times x times x plus x, right? That's what that means. So the most I can divide both of these by is just 1x, right? And when I'm simplifying that, x to the third divided by x, I get to take out one of the x's only. And then that just becomes 1. So that is x squared plus 1. Any questions? Questions why that's not 0? That's not 0 because I want to be able to come back. If I said x divided by x is 0, then I would have x times x squared, nothing, right? Plus 0. And if I wanted to recreate my original, x times x squared is x to the third, x times 1 is x, and here I would only have preserved the x to the third. So anything divided by itself is actually 1. They cancel each other out in that sense, but you still have to represent it. So that is x times x squared plus 1. Really all over the map with these letters. 5x cubed minus 4x squared. So now we're going to involve the x and the numbers. So we can rewrite that as 5 with 3 x's minus 4 with 2 x's. Okay, if that's easier to understand. So how I can't 5 and 4 don't really have any common factors because the factors of 5 are just 5 and 1. I guess I could write them. And the factors of 4 are 1, 4, and 2. 1 is a common factor, but that doesn't do anything, right? So there's no number that I can divide both 5 and 4 into. I have 3 x's here and I have 2 x's here. The most x's I can divide by is 2. So those two are canceled and this one is left with 1, right? So that's 4 times 1 or just 4. 5x to the third divided by x squared minus 4x squared over divided by x squared. Is that okay? Becomes 5x minus 4. And the factored out term is x squared, so it goes on the outside. For G, we will do both of them, both numbers and letters. Or I should say variables. All right, 8 and 12. What's the biggest number for factoring 8 and 12? 8 is 2, 4, right? Yes. 12 is 2, 3, 4. I guess we already did it, right? And 6. So the biggest common factor, we have 2 and 4, but the biggest one is, greatest common factor is 4. So I'm going to divide them both by 4.
5.
12 times 5.
I don't get that. How did you?
12 times 5.
Right, but like you said, 10 carries 1, and then there's 2.
5, 6.
Is it okay?
Which one's the multiplication? Was I talking to you?
Is that it?
No, we have 2 more steps to go. All right.
I don't get that.
What don't you get?
It's just,
You understand how these two couldn't divide out?
no, I'm just confused on how you got the whole thing in general. Like,
From here to here,
yes.
okay? 9 times 4. See it? 9 times the half. Okay? Equals
Is that this class?
24 in the quarter.
I don't think so. Sorry. I thought that was you guys in the classroom, like doing math by yourselves. All right. So x squared and x, the biggest term I can take out is x. 8 times, or sorry, so now I'll put 4x on the outside. 8 divided by 4 gives me 2, right? X squared divided by x just gives me x. 12, sorry, it's a positive 12 divided by 4. 12 by 4 is 3, positive 3. X divided by x cancels out. So that one is 4x times 2x plus 3. Any questions? That was a lively class. They were getting questions. All right. Factoring a difference of squares. So squares means that I've taken this number, and if I take the square root of it, right, I get a whole number. That's a perfect square. Okay. So the x squared is a perfect square because its factors are x and x. Positive 25 is a perfect square because its factors are 5 and 5. Is that all right? All right. With this one, you can check your answers by factoring everything back together. Or sorry, multiplying everything back together. Good? And then you can also look at your answer and make sure you can't divide 2 and 3 by anything, 5 and 4 by anything, 3 and 5 by anything. So that's how to kind of check your answer. All right, difference of squares. So the square root of a squared is a, is what they mean here. The square root of b squared is b, and these are whole numbers. So that's how you know you can use this. All right. So anytime you have a perfect square here and a perfect square here, you can just automatically change it to the 2 factors. Good. So for a, I have x squared minus 25. Notice that it's the word difference. So it'll only refer to subtraction. So the difference of two squares. What are my squares? I will always have an a and I will always have a b, right? Because this is a squared minus b squared. So the square root of x squared is x. My a is x. The square root of a positive 25 is 5. Any questions? Because x squared is x times x, and 25 is 5 times 5. So those are perfect squares. So we take the square root of x squared as our a, the square root of positive 25 as our b, and then we use this. A plus b times a minus b. Good. Now that I know what a and b are, I just write them again. X plus 5, x minus 5. So to factor x squared minus 25, it just turns into x plus 5 times x minus 5. It doesn't matter if this is first or if this is first, which term is first. Good. And if you want to check your answer again, we can go back and solve it by foiling it. X times x is x squared. X times a negative 5 is negative 5x. Positive 5 times x is 5x. 5 times a negative 5 is a negative 25. Those are like terms. X squared minus 25. So I know it's okay because I got back to my original answer. B, we have x to the 4th minus 625. That's interesting. So if you have a calculator that has this square root button, you can just say, what is the square root of 625? It's 25. What is the square root of x to the 4th? Do you know how to find that? You can. So anytime you're trying to find the square root of something with an exponent, you can divide that exponent by 2. Or you can just say, so I know that 5 times 5 is the same as 25, right? The square root of 25 is 5 because anytime you have a pair under the radical, if the radical is only for 2, you can take that out. So for this one, we have a radical of 2, and then we have 4 x's, right? Under it. Anything that's a group of 2, you can take out. So this is a group of 2 x's, and this is another group of 2 x's. So what that leads to is x times x, or x squared. So that is how I know that a is x squared and b is 25. I can't really put x to the 4th. I can't take the square root of x to the 4th with a calculator, but I can divide this number by this number. Or I can think about how many x's there are and how many I can take out. So again, a plus b times a minus b. Rewrite it as x squared plus 25, x squared minus 25. Don't worry about then taking the perfect square of this one, right? You could say that that is x squared plus 25 times x plus 5 times x minus 5 if you wanted, but they're never gonna get that complicated. But basically, because that's the same as that one, or that one has perfect squares, you can also write it like that. Only the minus, not the positive one. C is 4x squared minus 49. So we want to check, is 4 a perfect square? Yes, right? Because 2 times 2 is 4. X times x is x squared. So A is going to be 2x. B, remember, positive 49. So what number times itself is 49? A positive 7. Good. A plus B times A minus B means it becomes 2x plus 7, 2x minus 7. It's okay if your minus is in front. Letter D is 100 minus 64x squared. So again, you can use this button, or you can even say, what's 2 times 2? It's 4. What's 3 times 3? And just keep going up until you find that you've gone past the number you're looking for, or you found it. So the square root of 100 is 10. The square root of 64 is 8. So A is 10 and B is 8x. Don't forget the x squared becomes an x. Good. We have A plus B times A minus B, which is 10 plus 8x times 10 minus 8x. Any questions about the difference of squares? This is often just something I recommend putting on your note card if you have not memorized it. So that was only the difference of squares. Now we have the sum or difference of cube. We okay with what the meaning of cubes is? So cubes means that this is a 3 instead of a 2. Good. So we need to factor x cubed minus 27 and x cubed plus 64. You can also call it x to the third. So we want to know, is 27 a perfect cube? You can just do this, or you can say, I don't know. It means it's 3 times, right? Or 2 to the third, 3 to the third, 4 to the third. Kind of like that. Find it in a backwards way if that is better. So here, A is going to be x, right? Because x times x times x is x to the third. B is going to be the number 3, because 3 times 3 times 3 is 27. And remember, it's not negative 27, it's just 27. And then you use the model with the minus sign in it. A cubed minus B cubed equals A minus B times A squared plus AB plus B squared. I like to write this all out, and I like to write out A and what A and B are, because if I don't, I'll just start writing these as A and B and make a mistake. So x minus 3 times x squared plus 3x plus 3 squared. And then I'm just going to change 3 squared to 9. Is that okay? All right, and I can even show you how this works out backwards. So if I distributed the x and the negative 3, I'm going to get back to x cubed minus 27. X times x cubed is x to the third. X times positive 3x is positive 3x squared. X times a positive 9 is 9x. Now the negative 3x squared. Negative 3 times a positive 3 is a negative 9x. And then negative 3 times a positive 9 we know is a negative 27. because 3 times 3 is 9, 9 times 3 is 27. Now I put them in descending order of the exponent. So x cubed plus 3x squared minus 3x squared. Again, you do not need to write down everything I write down, right? If this is too much detail, you don't need to worry about it. X cubed, those cancel. 3x squared minus 3x squared becomes 0. Positive 9x minus 9x becomes 0, minus 27. So we got all the way back to our original expression. Letter B is just an opportunity to practice now the sum of two cubes, because sum means add. So B was x to the third plus 64. What is A and what is B? Again, A is something that I can multiply 3 times, multiply by itself 3 times and get x to the third. So that's going to be x, because x times 3, or sorry, x times x times x is x to the third. B is going to be, what do you think? It's not 2, right? It's not 3. It's 4. Because four to the third, right? So A is x, B is 4. Again, it was A, now we're doing the addition, the sum. A plus B times the quantity A squared minus AB plus B squared. So if I substitute that in, that becomes x plus 4 times x squared minus 4x plus 4 squared, or plus 16, right? So those are the sum and difference of cubes. I definitely write those down just to not mess up any of the minus signs or the plus signs. Placements. Factoring by grouping. This seems more difficult or more random sometimes than it actually is. Factoring by grouping is what you do when you have, this is for when you have 4 terms and no common denominators. Factors, I should say. Good. So the first page, those were all common factors. See if I can even find it. Those all had common factors. This was 2 was common to 4 and 2. 5 was common to 5 and negative 10. 2 was common to 8, 4, and 2, right? Here I have 3x squared minus 3x plus 2x minus 2. Nothing is common to all 4, okay? It's called grouping because I'm going to group them into groups of, guess how many? 2. So I'm going to take the first 2. Oh, you can't see it. Huh. Oh, I'm like not directly overhead. I have the first 2 there, and then the second 2 there. So I'm just grouping them and factoring out something from that group. All right. Splitting it right down the middle. So first I have 3x squared minus 3x. What can I factor out of that? An entire 3x, right? So that becomes 3x. 3x squared divided by 3x just leaves me with x. Negative 3x divided by 3x leaves me with a negative 1. So that's my first group. Second group was a positive 2x minus 2. Always don't change this sign when you're factoring something out. So if this is a positive, make sure the term you factor out is also positive, okay? 2x and negative 2. I can factor out a 2 from both of them, right? So 2x, sorry, I'll put the 2 here. 2x divided by 2 is just x. Negative 2 divided by 2 is a minus 1. Now, what I have, if I were to line that all up, right? If I did this right below that, it would look like this. 3x times x minus 1 plus, to preserve that sign, okay? Plus 2 times x minus 1. Now, oddly enough, I have a common factor, right? Here, if it was 2y minus 6y, my common factor is the y, right? Because I'm multiplying this y by 2 and this y by the 6. Here, I'm multiplying the 3x by x minus 1. I'm multiplying the 2 by x minus 1. So x minus 1 is my common factor. So I take that out now, all right? I take out the x minus 1. And I multiply it, just like I multiplied, right? I multiplied the 3x by all of this. I take out my common factor and I multiply it by the two terms that were left. Good. And so if I were to go backwards through this and say x times 3x is 3x squared, x times 2 is 2x, negative 1 is negative 3x, negative 1 is 2, times 2 is negative 2. Oh, and also, why didn't we just combine those two? Anyway, you get back to the same four numbers or four terms that you had in your polynomial. Why we didn't just combine like terms with the 3x and the 2x though? So our final answer to factoring by grouping is right here. B, we have x to the third minus 4x squared minus 2x plus 8. Because of that 8 here, I can't take out an x. Because of this x cubed here, I can't take out a 2. So there are no common factors. So I'm going to do factoring by grouping. I'll try to do it right below this time, so it looks more like this right away. So x to the third and negative 4x squared. What can I factor out of both of those? Just an x squared, right? So now I have x squared. X cubed divided by x squared is just x. Negative 4x cubed divided by x cubed is minus 4. Good. And then over here, now it's a negative 2x. So this is when I said preserve that sign, make sure that sign goes with whatever you're pulling out. So negative 2x and 8 can both be divided by negative 2. Okay, I have to make this term a negative because of that minus sign. So negative 2 is what's being factored out. 2x divided by negative 2x is a negative x. 8 divided by negative 2, oh, sorry, it's a positive x. Negative divided by a negative is a positive. And then 8 divided by a negative is a negative 4. So the reason this had to be negative is because we need these two numbers to be the same, right? So if I had said positive 2, that would have been a negative x and a positive 4. Because it's a negative 2, these still look the same and I can pull them out. So that is x minus 4 times x squared minus 2. Okay, that is factoring by grouping. You'll kind of know you did it right when both of these match. You'll definitely know you did it right if you go back and refactor it, re-boil it up. All right, now we will practice for a little bit. Hold on. sorry, got a little behind. X squared plus 8x plus 16. So what you want to do is you want to find right here something that, oh, okay, well, first let's introduce a x squared plus bx plus c, right? So here my a is 1, my b is 8, and my c is 16. When your a is just the number 1, what you're going to do is you're going to find for this x squared, you're just factoring out x squared becomes x and x. And then for these last two terms, you want a number that multiplies to equal 16 and that adds to equal 8. Or multiplies, what would be better is multiplies to equal c, adds to equal b for all of these, okay? So what are the factors of 16, the factor pairs? So you have 16 and 1, you have, sorry, I wanted to put the 2 here. You have 8 and 2, you have 4 and 4, right? Do any of those add up to a positive 8? 4 and 4 add up to 8, right? So those are the numbers you choose when factoring x squared plus 8x plus 16. You can also call that x plus 4 squared. Good. Something else you can try. If this is a perfect square and this is a perfect square, you can just try taking the square root of that one, putting it here, taking the square root of that one, putting it here, and squaring it, right? So x squared is x squared, 4 squared is 16. So over here, the square root of 4x squared would be 2x, right? And then the square root of 9 is 3, right? So is that true? You're gonna have to FOIL it out to make sure that it adds up to 12, because 2x times 2x will give you the 4x squared. 2x times 3 will give you 6x. 3 times 2x will give you 6x. 3 times 3 will give you 9. So that one's okay. So if you have perfect squares on the ends, you can try just making it into those perfect squares squared. Good. All right. So here, square root of 9x squared is 3x, right? The square root of 16 is 4. 3x plus 4 squared. And then you can check it. Three x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x again. 4 times 4 is 16. So if I combine those 12, I'll get that 24. So that one works. x squared plus 9x plus 14. So now this one is not, 14 is not a perfect square, right? So I have ax squared plus bx plus c. So b is 9, c is 14. I need it to multiply to 14, add to 9. So it needs to add to equal 9, those two terms, and it needs to multiply to equal 14. But I do know that it will start with just x times x, right? All right, what are the factor pairs of 14? We have 1 and 14. We have 2 and 7. I think that's it. You could also say -1 and -14, -2 and -7. But since it needs to add to a positive, you really only need to include the positives. 14 plus 1 is 15, 7 plus 2 is 9. So this one will work. So x plus 7, x plus 2, or x plus 2 times x plus 7. X squared minus 7x plus 10. It needs to multiply to equal c, add to equal b. My c is 10. My b is a -7. So in this case, it needs to multiply to a positive, add to a negative. So it's going to be two negative numbers, right? So it could be -1, -10. It could be -2, -5. And that adds to -7, right? So we're going to say it's x minus 2 times x minus 5. Again, because a is just 1, we can always call the first two terms x times x, right? Here, what we need is, I'll bring it down here, x squared minus x minus 20. We need it to multiply to equal c, add to equal b. C is a -20, b is a -1. Multiply to equal -20. -20, +1, 20, -1, 2, -10, +10, -2, 4, 5, 5, 4. All right. Which one of those, if you added them, that would be -19. So that's no. +19, -8, +8, +1. But this one is -1. So we can say that the answer to this is x minus 5 times x plus 4. Here we have x squared plus 2x minus 15. We need it to multiply to equal c, add to equal b. So it needs to multiply to equal -15, add to equal 2, -1, +15, 1, -15, 3 and 5. And it needs to add up to 2. That looks like this one, right? So this will be x minus 3 times x plus 5. last one. How much time do we have? 4 minutes. Good. 3x squared plus 10x plus 3. All right. This is a very different one because it's not 3 is not a perfect square, right? So we can't do these top two, but it's the only one of these examples that we've tried where a is not 1. So we have a x squared plus bx plus c, where a is 3, b is 10, c is 3. So if a is not 1, now what you have to do is it needs to multiply to equal a times c and still needs to add to equal b. 3 times 3, and it still needs to add to equal 10. So it needs to multiply to equal 9, add to equal 10. What are two numbers that you can multiply them together to get 9 and you can add them together to get 10? Just a 9 and a 1, right? Okay. You don't simply go x plus 9, x plus 1. That won't work, right? You can tell right away, even though it is 9 and 1, you can tell right away that x times x is not going to give me 3x squared. Instead, what we had was 3x squared plus 10x plus 3, and we got the factors 9 and 1. What we do is we replace this 10x with 9x and 1x, okay? That's where those go. So when you have to do something like this and you find your two factors, they don't go here. They replace your middle term. They replace your b. So b is now replaced with 9x and x. A stays the same. And c stays the same. Good. And then we practice factoring by grouping because now we factor by grouping. It does not matter whether you put the 9x in front or the x in front, okay? You'll still get the correct answer. Don't worry about the order of these two. But we'll group this, 3x squared plus 9x. I can divide them both by what? 3x, right? And what I get is 3x divided by x plus 3. Positive x plus 3. So that has to be a positive. There's no common factors. I can just say 1. That's okay. X divided by 1 is x. 3 divided by 1 is 3. But you see that we still get the x plus 3 as a factor, and then 3x plus 1. Good. So this one up here is not x plus 9, x plus 1. It is x plus 3, 3x plus 1. Zoom all the way out. All right, you guys can go. I think I kept you over. Ooh, I apologize. Right on time. All right, email me if you have any questions, though. Make sure you're in the right class.